class, great to see you here. In this video, we are going to learn the binomial distributions, which is one of the most well-known discrete probability distributions. First of all, students have to learn how to identify the binomial distributions. Second, they have to know how to find the mean and variance of binomial distributions. And finally, they have to find the probability by using the binomial distributions. Before we proceed, let me introduce what is called by binary triad. The binary triad is a triad that have two possible outcomes, that is success or failure. Normally, we denote the probability of success as P and probability of failure as Q, whereby Q is the complement of P, so we may get the probability of Q as 1 minus P. The binary triad is repeated n times and each triad is independent, so the probability of a success stays the same for each triad. In other words, we can say that the binary distributions represent the success or failure of a single binary triad. What is binomial distributions? Binomial distributions represent the numbers of success and failure in an independent binary triad. Here is the examples of binomial distributions. Let's say a coin is flipped 100 times. What is the probability heads come out at least 60 times? We will see that we will be able to use the binomial distributions to calculate the probabilities. Here is another example. You buy a certain type of lottery tickets once a week for 4 weeks. So, what is the probability you win a cash prize exactly twice? Well, this might sound a little bit different from the tossing coin examples, but from a perspective of probability, it is really the same type of scenario of binomial distributions. Therefore, a lambda variable is a binomial if the following 4 conditions are met. First, there are n triads. Second, each triad has 2 possible outcomes, success or failure. The probability of success called P is the same for each triad. And finally, the triads are independent, means that outcome of one triad doesn't influence the outcome of any triad. Let's say S denotes the numbers of success in n triad. The probability of success of any triad is P and the failure of Q is the complement of success. The X has a binomial distribution with these probability distribution functions. The probability, the lambda variable X take on the value of little x. Sometimes we write it as P of little x. This is the probability we get little x success in n triad. That is, the probability of success P rise to the numbers of success X times the probability of failure Q rise to the numbers of failure, which is n minus x. We multiply that with the numbers of way, we get x success in n triad, which is n choose x. Take note that the n can only take the whole numbers from the 0 to n. We may get the binomial probability by these two methods. First, we do the calculations from the probability distribution functions formulas. Second, we may get the value of probability from the binomial probability tables. Take notes, in the binomial probability tables, the probability is the x is larger or equal to r. So, in order to answer the questions, normally we are going to apply these 3 formulas. So, we may get the probability of x equal to r by using probability of x greater or equal than r minus the probability x greater or equal than r plus 1. For the probability less or equal than x, you may use the 1 minus the probability x greater or equal than r plus 1 from the tables. And for the probability x is less than r, we may use 1 minus the probability of x greater or equal than r. So that means that we may read all this from the binomial tables. Let me show you how we're going to memorize these 3 formulas. Let me show you how I'm going to use the Petua Gigi puzzle in helping me to form the formulas. For the first formula, so we draw 3 teeth here. So I'm going to remain the teeth x equal to r here. So that is why from the tables, so I will read greater or equal than r, subtract with the probability x greater or equal than r plus 1. This is why I'm going to remain my probability of x equal to r here. For the second formula is the x less or equal than r. That means I'm going to include my r here. So this is why I will use my total probability 1, subtract with the probability x or equal than r plus 1. So I'm going to subtract here. So I'm going to remain the probability which is less or equal than r. Okay, for the third one, so since the question here says that less than, so not going to include r. So if we look at our tip here, less than r, so that means I'm going to remain my this side. Okay, so that's why I read the total probability, subtract with the probability greater or equal than r, so I have the tip of less than r. So in other words, this one is equivalent to x less or equal than r minus 1. So this is how the petua gigi palsu help us to form the formulas. This is an example of binomial probability tables. If you want to read from the probability tables, we are going to read based on the number of n trial, the number of x sources, and the probability of sources. Not every probability that we can find from the binomial probability table because there is a limited range of the parameter value of n and p. For your information, we only can read from the table in the range of n equal to 3 until n equal to 50 only, and for the parameter p, we can read from the range of 0.01 until 0.5 only. If the value of probability is not included in the tables, we can find the probability by using the probability distribution functions formulas. The mean of a binomial distribution is called the expected value. It is equal to the mu or equal to n times p. The variance, sometimes we call it as the sigma square, is equivalent to m times p times q, and whereby the standard deviation is equivalent to the square root of mpq. Let me show you some examples of binomial distributions. Look at example 1. We have 40% of the students in a school wear spectacles. From a sample of 10 students chosen at random, find the probability that only 3 students wear spectacles. B. More than 7 students wear spectacles. This is an binomial distribution. Method 1, we are going to use the probability distribution functions. For these cases, the x is the numbers of students wear spectacles. So we are going to find from the sample of 10 students, the probability of wear spectacle is p 0.4, whereby the probability does not wear the spectacle is q is 0.6. So this is an binomial distribution with the parameter 10 and 0.4. So we are going to find by using the probability distribution functions formula. So for the first case, I'm going to find the probability only 3 students wear spectacles. That means the probability x equal to 3. So by using the binomial distribution functions formulas, we substitute the corresponding value. So we are going to get the probability of 0.2150. For the questions B, we are going to evaluate the more than 7 students wear spectacles. So that means that I'm going to find the summations of probability 8 students and probability of 9 students and probability of 10 students wear spectacles. So by using the probability distribution functions formulas, again we substitute to the corresponding element and value. So we are going to get the probability as 0.0123. Besides that, we may also use the method 2 binomial probability tables to solve this problem. So we go to the page, we have the n10 and the p is 0.40. So that is the page number 6. So this is the columns that we are going to emphasize. So for the first question, so we are going to find the probability x equal to 3. So we may apply the petua gigi palsu, that is the probability of x greater or equal than 3, subtract with the probability of x greater or equal than 4. So we read the value from the tables and we subtract it. So we are going to get the answers of 0.2150. For the second question, since we're going to find the probability greater than 7, which is equivalent to probability x greater or equal than 8. So this is the value that we are going to read. So we can get the value directly from the table, which is 0.0123. For the example number 2, x is a random variable of a binomial distribution with the parameter n equal to 10 and p equal to 0.45. We are going to find the value of a for the following conditions. These questions can be easily solved by using the binomial distribution table. Let me show you how to do it. For the questions A, I'm going to find the probability x greater or equal than a equal to 0.4956. So we apply the petua gigi palsu. So if we look at the x is greater or equal than a, so the included region is the a plus 1, a plus 2, and so on. So you go to the statistical tables. So go to the page, we have the n equal to 10 and the p equal to 0.45. So from the statistical table, we try to search for the value of 0.4956. So you will get this. So it will be happen in the column of when n equal to 5. So therefore, for these questions, the value of A is equivalent to 5. For the questions B, we are going to have the probability of x less than A is equivalent to 0.89801. So from the petua gigi palsu, the included region will be the less than A is the A minus 1, A minus 2, and so on. So we try to rearrange. So we are going to have the 1 minus probability of x greater or equal than A equivalent to 0.89801. So we rearrange the value. So we're going to have the probability of x greater or equal than A equivalent to 0.1020. So we're going to read this from the binomial table. So we go to the page of n equal to 10 and the p equal to 0.45. So this is the region. So we find the probability of 0.1020 is at the row of n equal to 7. So therefore, for these questions, the value of A is 7. For the question number C, so again to evaluate the probability of x equal to A is 0.2384. So from the petua gigi palsu, so the region will be the A only. So we have to use the probability greater or equal than A, subtract with the probability of x greater or equal than A plus 1. So we go to the statistical tables of the page that have the n equal to 10 and the p equal to 0.45. So we do the subtractions for any two rows, so until we will get the 0.2384. So that is from the x equal to greater or equal to 4 and x greater or equal to 5. So we are going to get this value. Okay, so that means, so for these cases, the value of A is equivalent to 4. For the example 3, so we have the binomial random variable x with the binomial distributions with the parameter n and p. So these distributions have the mean 3 and the variance of 51 over 20. So we're going to find the value of n and p, and hence we're going to find the probability when x equal to 3. So let me show you how we're going to solve this problem. The very first equation that we confirm is from the expected value 3, that is the NP equal to 3. And for the variance, so you may have the NPQ equivalent to 51 over 20. So we solve these two equations to get the value of Q as the 17 over 20. After that, so from the value of Q, so we may get the value of P by using the 1 minus Q. So we have the value of P as 3 over 20. So finally, so we may get the value of N as 20. So this is the binomial distributions with the parameter 20 and 3 over 20. So after that, we may evaluate the probability of x equal to 3 by using the binomial distributions formulas. So to get the value of probability 0.2428. Before we end this video, so I have questions for you to try. So you may try to get the answer of n equal to 11. Okay, that's all for this video. Thank you very much for watching.